any exam questions. I've picked a random selection of questions that we can have a look at today. And then, unless you have any other pressing questions about anything. No? Okay, let's have a look at this one. Have you read through it? Yes? Yes?
Yes.
Excellent. So what does it remind you of? What does it say? In general, there aren't so many different models that we've done that lead to an integer or linear programming formulation, are there? So we had some problems that looked like the knapsack, which you also know from dynamic programming, but you also know it from the integer formulation. Then what else did we do? Aggregate planning, which was just linear programming, so you don't want any integrality there because you're trying to make it easy and quick and not necessarily very precise. Batch planning, where the setting up of batches is an integer variable, 0, 1. So this is what it says here.
Okay. I'm wrong side. I read the wrong question.
Yeah, never mind. We'll come to that one in a bit. So it's not in vain. Okay. So what do we know here? What are the data or parameters? You don't have to, but you can if it helps you. You can summarize the data. So 1 to 8 is the set of light bulb types. Right. And T, 1 to 20, is the time horizon.
Visualize it the way it's initial.
Yeah. And then there is QJT, demand for product J in week T. And AJ is the setup cost for, well, product type, so light bulb type J. No. Says that there's no limit on storing. Amount can be stored, but there is a cost, which is G. Stock holding cost, if you like, storage cost, stock holding cost. And there is the initial stock IJ0. The initial stock of type J. Can you see any other data in the text? No?
Oh, it's
Yeah, I made the same mistake. IJ0.
that's what was like. What I was trying to figure out what was a triple.
IJ0.
No more than one batch of each type is produced in any given week.
Yeah, so okay, that's good.
I mean, it just says it.
Yes. Right. Decision variables. What are they?
PJT.
Run out of ink. I've run out of ink.
Right. Oh yeah.
Sorry, what did you say?
Big PJT.
P.
Yeah. So it's the amount produced of product J in week T.
Amount of type product type J produced in week T. That's right. And the other ones?
Storage.
So say this is 5. Storage. So
Just SJT.
I'll call it IJT because it's
Because
response to the initial one. So I'll call it stock level or storage or whatever you want to call it. At the end of week T. Or type J. Anything else we need? Anything else we need?
It's binary variable, isn't it? For the setup constant. Whether or not we're producing in a week or not. So the BET.
B.
Not just anything for the binary.
Yeah. I think we usually call them delta. Doesn't matter. You can call them B. But they have to be different for each batch.
Producing that batch per week.
Yeah, because you want to. For each of them, you need to do the setup slightly differently. That's the idea.
Mm-hmm.
So this is binary one, which is one if a batch of J is produced in week T, and 0 otherwise, and all of them are for all J in J and T in T. All right, what is the objective? You wrote minimize. Okay, I'll copy that. Minimize.
I don't remember which way around all this goes. would be
On your right, the sums you should put
J and J and T is T.
limits, sets, the indices come from. There are two kinds of cost that we're taking into account in this model, because there are two kinds of costs that are mentioned.
Setup and start.
There are obviously other costs, but they're not relevant. So, for example, the direct production costs are the same no matter when you do it, because you just have the demand that you have to satisfy, and that's going to be the same. Or at least it's not in this example. Sometimes you could have a batch production planning thing where the cost depends on which period you make them in. But here it's not mentioned, so it doesn't. So there's the storage. So there's the storage cost, which is G times P JT is what it was, and then the setup cost is AJ times whether we make the setup or not, 0 or 1, and that you have to add.
Why is it P?
You said P. Oh,
It should be I,
it's not.
shouldn't it?
It should be I. You're right. Yes.
Otherwise,
So
it's just going to be P minus Q, which is a constraint.
yes. No, you're right.
Otherwise, it's a
It
constraint.
should be I. What are the constraints? Going backwards.
Takes me one on the next page.
Okay. So in the constraints, usually you have continuity. So for each product group and each time period, continuity is that what I find at the end of the previous week, or the initial in the first period, plus the production in the current period, is what I get rid of, plus what I store at the end. Sometimes you can have a problem where there's backlogging, so you can run short of stuff, and then you add the backlogs on the left side here, but not in this question. So that's the continuity, and then the other important constraint is what? Set of constraints, because they're not actually. Just kidding. Get rid of that one. Set the boundary constraint. It gets it out of the way. I don't want to get it out of the way. Okay.
It's just the obvious one, not such as.
J in J. Yes, delta JT is a 0, 1, and all the other ones, P's and I's, we want them to be non-negative. Yes. What's missing in here? In the middle? So one test of whether your formulation makes sense. It's not it doesn't guarantee that it makes sense if it passes the test, but if it doesn't pass the test, then there's something wrong. And that is that you check that all of your decision variables appear somewhere in the constraints, not just the non-negativity or binary, but in functional constraints. Okay. there are some decision variables that don't appear in any constraints, then there's something wrong. Either you have enough constraints and then you have too many decision variables and you should strike them off the list, or your decision variables are right and you're missing some constraints. So which variables are not appearing in any constraints here? Binary. What are they there for? You need to make sure that you're not producing anything when you're not setting up, right? That's important. So keep that in mind. If you see a batch planning formulation, let's say PJT. No. Okay, here it says linear, and that means you can't times two decision variables.
Yeah.
So
That makes it quite.
exactly. But the trick is you take some large number m.
But no.
So if there is a limit on the amount of production in any single week,
Set it there.
you can set it there.
Except if it's on the it's just no.
Yeah. In practice, in the formulation that you're not supposed to solve, just put a large constant. For example, you could take the sum of all the demands. That would definitely do, because you don't want to produce more than the sum of all the demands. So that is one option.
Mm-hmm.
Okay, I think that's everything. Any questions about this? No? What's part B?
Work hours.
Part B, now you have R hours. So there are some new parameters. R, UJ for setting up, and KJ for producing a light bulb. And you just need to, for question B, you just have to give the additional constraints, keeping in mind you have everything in the old formulation. Or if you're replacing something, you can just say, I'm replacing this or that. You don't have to repeat everything. And in this case, it's just an additional bunch of constraints, which make sure that you don't go over time. So for each, oh no, not for each. Sorry. It starts very well. So in every time period, you must not go over the available time. So for each t, something must not be larger than r, right? What's that something? What do you have?
UJ times by so.
UJ times delta JT. Okay, but then there's also the production time, KJ, for one bulb.
Oh, yeah.
So you need to add how many hours you need for one bulb times the production of these bulbs in that period. Okay?
Absolutely.
So this in the bracket is the time needed for each of the types, and then we need to add them all together. And that gets the extra constraint. That gives the extra 3 marks.
True in the fact that it just says a new set of constraints is just there to confuse people. You only need one.
No, because there are 20.
Oh, I see, because it's got the, yeah, I know what you mean.
So it depends on how
Unity.
you call it, but
Otherwise,
yes. So in some sense, it's one constraint, but in fact, it's not just one constraint because it's one in each week, which I call a set of constraints. So if you see a set of constraints, yes, it just be.
It's going to be a for all in there at least.
Be lenient with me. Sometimes it can say a constraint, and it might mean a set of constraints.
Okay. Yeah.
And sometimes it'll say a set of constraints might be a set of constraints, which is just really one formula, but indexed by something.
Okay. Yeah, that's fine.
They're not very, probably not very consistent using this.
It's either going to be 2 constraints with summations, or it's going to be one that's got, it's over the whole thing.
Say it again?
It's either going to be one with a sum, or it's going to be one that's over the full set. It's okay, I know what I mean.
There will be something. Yeah.
Yeah.
So this is the extra thing that you need to add anyway in this case. And this is just another set of constraints.
Do you mean when it says stock, it means the storage?
Yes. So you need to add a constraint that takes care of it. Or a set of constraints rather. It's limited at every week. Every week, the total number of light bulbs we have is no more than 7.
Okay.
End of constraints, another 2 marks. Already 15.
What sentence is it?
Now we can stop because that's already a first class mark.
How to get the rest of the marks?
So D is talking about the dynamic programming model, the dynamic programming approach to batch planning. And there are some conditions under which we said you can use it. And those conditions are, can anybody remember? So there's but one product only, or independent products.
Effectively, when we did the one with the magnets for the coursework, that wouldn't work because they weren't independent with the coils.
That's quite right. So when you have coils, where you have magnets that depend on some coils that you're also doing the batch planning for, then you can't use it. And this problem that we just been solving, when there is part A, you've got 8 different types of light bulbs, but they don't interact in any way. It doesn't say that if you're making one, you can't make the other, etc., etc. So you could apply it to problem in part A here as well. But as soon as you get the modifications B and C, and they're no longer independent, because you're adding all the types. makes them not independent. But moreover, there's a second assumption that you need for the batch planning model, which is that there are no capacity limits.
Which is what we've just said in the extension points.
Yes, exactly. So if you have a capacity limit on how much you can produce or a capacity limit on how much you can store, then you can't use the batch planning. Or you can attempt to use it, but if you get a solution which is not feasible, then it's not good. But, it's not guaranteed to work, because if you remember, what we did was there was this lemma that we only produce when we have 0 in stock. And that an optimal solution looks like this. So you produce for a certain number of periods everything you need in the coming couple of weeks, and you just have to decide how many weeks you need to produce for. So that's how the algorithm goes. And what does it ask to? Now it wants a brief description of the algorithm. Which I'm not very keen to go into.
That's fine.
Because it's somewhere in there. So one way to describe it is starts on page 33, 37. In first booklet we have so mathematical models. Or if you don't want to describe it in the way which is in the book, you can as well describe it by the shortest path. Well, although we had, if you remember that, so we had 20 and 21 at the end. Or you can say shortest path in the graph. The vertices, the vertex set is a set of all the time periods. Well, it's actually T and an additional n+1 vertex, which is this 21 here. Describing it in terms of the 20 period. And then there are arcs going forward from any vertex to any vertex in front. Okay, so arcs from J to K. No, J is less than K. From any small number to any large number. And shortest path goes from 1 to 21 for n+1. Want to be more general. And the only thing that remains is the cost function, so the cost of an arc. J to K is well, A, which is the setup cost, because it means we're producing in period J. Okay, I should probably different letters because I was using J for the product type. So now I'm using it for a period. I apologize, but it just so happened. So you have to do the setup in period J, and then you need to keep the magnet. So G is the storage cost. And you keep them in periods. So for J plus 1, and you end in K minus 1. Because you keep something into period J plus 1, period J plus 2, and so on. And in period K, you will be producing again. So K minus 1, you stop. You need to look at how much there is to keep. And the number of months that you keep it for. So that's something like T minus J. So either you describe it in stages, states, whatnot, or just give the graph. That's good enough for my question. If Philip asks you to do the stages, then you have to say what the stages are. Well, you could say what the stages are. I mean, the stages are, there's just one state per stage. Each of the vertices is its own stage. And the transitions are like this, and the decision is, what is the next month going to be when we, or next week going to be when we produce, given we're producing in the month, in the week that we're in. Okay, good. So that's finished. Now, I just very quickly want to have a look at somebody else's paper. Incidentally, this is also question 5. Which was before I was born, or at least before I joined this university, so it was said by somebody else. 4 strategies. So part A, pages 13 and 14 of the same book. So it says, how do you deal when you have seasonal demand, with fluctuations in the demand? So one way of doing it is you plan backlogs. Sometimes you can do it. Then it says large inventory. So you just produce a lot when the demand is low and store it. Workforce changes and overtime or overtime. And then there's a strategy of complementary products. So if you're producing sunscreen, you should also produce something that's needed in winter in the same factory. Okay. Part B is, so now this is an aggregate planning formulation. And I'm not going to list everything. There are quite a number of different.
I thought the question was 3 marks. I realized it's split 2.
Few available hours, 1 hour of overtime for every 5 hours of regular time. It takes kj to produce. There's a cost, overtime cost is O. VJ is the direct production cost. The holding is CJ. I think.
That's a question.
Pardon? Oh, I'm just making one. So J will be the product groups 1, 2, 3, 4. Says there are 4. T is 1 to 12 is the time horizon because it wants us to produce over the 12 months. And that's it. Every letter which is defined in the text of the question, or every symbol, you don't have to repeat in the answer if you don't want to. You can, if you want to make it clear for yourself that you're using these letters, then you can list them. But you can use them in your formulation if it's stated something like QJT in the text. You can just use QJT, and it's already given in the question, so you don't have to repeat words. What you have to do is you have to give your decision variables. So here it wants a linear programming model, not integer. Do you have the decision variables? BJT. Amount of product group. J produced in month T. And IJT, amount stored. At the end of month.
See, yeah, sorry. Trying to find it in the question. The last line.
But you also need the WJ, so that's worker hours. Worked in, oh no, sorry, not JT. Worked in month T. In regular time. Let's say OT. This is overtime. Hours in month T. Okay, I think these are there. Then the objective again is to minimize the cost. Is that right? Out. Now we're adding over the time period. Okay, so what are the costs? The worker hours cost. So R for every regular worker hour. O for every overtime worker hour. And the rest we have to sum over all the products. So VJ is the direct cost of production. And storage is CJ times how much we store. I think that's all the costs that are there. And I have to put the right brackets around it. So, you know what the sums on there. So these two things and everything in the other bracket. And constraints, we'll probably say continuity.
This decision variable.
So what you need is t minus 1 plus what we produce equals what we sell plus what we store, that. There should be a note that ij0 is initial stock or inventory level. Just make sure that we are accounting for enough worker hours. Okay. So in every period, the amount of worker hours that we need, there is AJ times production. You need to add this over all the J's. Yeah, so this is the time we need, I think. I'm rushing a bit, but it's almost time. So.
Never enough time.
Yeah, so this is what we need, and what we have is W plus O. And we must make sure that we're not using more than is available, so WT no more than Rn, and OT is no more than 1 in every 5 worker hours that we're using. You could probably interpret these things in various ways if you insisted. And of course, you always need non-negativity constraints, so PJT and IJT and WT and OT are equal to 0. Basic test, all decision variables appear in some constraints, W, O, P, I, yes. Do all parameters also appear somewhere? Okay, QJT, yes, it's in the constraint. Rn is how much we use, 1 in 5 is there. KJ is somewhere there. R is there, O is there, BJ is there, CJ is there. Sometimes it can happen that there is an additional piece of information that you don't really need for anything. So that test, that's a test that can give you a hint that you're missing something. But the decision variables really should all appear, because if they don't all appear, then they shouldn't be on the list of decision variables at all.
As long as the data is mentioned in at least somewhere.
Well, sometimes
As long as it's in the objective or
most of the time it will appear somewhere. It can happen that there's something to confuse people, which is not relevant.
in the curveball.
Say that the speed of the train passing the factory is 20 miles per hour. Okay, I think there's everything to just think about. They're probably not so easy questions, because you have to get the language of maths right, and you have to keep in mind all the constraints in the real life situation, how they reflect formulation, and just go through it one more time to see that you haven't forgotten anything. Okay, so this was somewhat artificial questions split into part 1 and part 2. This would have been 1 and this would have been 2.
Okay.
It says 1 list of decision variables and 2
do everything else.
Do everything else. Okay, so we've done 2 questions, and 45 minutes, which is reassuring.
Do 3 more in about an hour and a bit, and you go away.
Yeah, you have 2 hours left.
And you do the other 3 in about an hour and a half, and then check the rest of it.
Oh,
and
yeah,
decide.
okay. Then you can go home.
Yeah.
All right, any more questions?
I'll
Oh,
remember
good
the
luck.
question I had, I'll email you.
Okay, yeah, you can email me.